Hey guys, so in this video we are going to solve topological sort problem which is from Geeks for Geeks. So problem state that we are given a directed acyclic graph. What is this directed acyclic graph? That means direction is specified like between u to v, and there is also a cyclic graph. That means there will be no cycle in that graph, and we are also given this edges of y which represent the u to v. That means u node to v node there will be one edge. Okay, fine. And we have to return a topological sorted array. What is the topological sorted array? So let's suppose I have one graph which is connected like this was like let's take this example 3 0 then 1 0 then 2 0. So here 3 is connected with 0, 3 to 0, then 1 to 0, then 2 to 0. So what will be the answer? Like let's suppose let's take an example like 1 2 3 4 5. So let's suppose this is one output. This one's topological sorted array. So which means that 5 which always comes after all its parent. Let's and this 4 it always comes after all its parent. Then same for the 3 which comes always after all its parent, that is 1 2, and this 2 always comes after all its parent. Fine. And here let's check this example. So for this one topological sorted array is like 3 1 0 and 3 to 1 and 0. So here the 0 whose parents are 3 2 and 1. Here we can see that the parent of 0 are 1 2 and 3. So these all comes before 0, and here like 1 there is no any parent of 1, there is no any parent of 2, there is no any parent of 3. So these 3 are independent, so they can join together. Fine. So this is a topological sorted, and we have to okay. So in this video we are going to solve this problem using Kahn's algorithm. So what it states, like let's take this example. This is one graph like here G to B, then F to A, then B to A, then E to A, and goes on. So what we take first, we first take those nodes whose parent are 0, like whose parents are none. So first we take this G, then E, then C, then F, then H. So here these nodes that do not have any parents, so like we can start with these nodes. Yes. So after this like we can go with like G to B. Actually that Kahn's algorithm is a BFS approach. We can also use DFS approach, but this Kahn's algorithm is a BFS approach. And first after selecting this nodes whose parents are none, then we shift to its neighbors, and we do the same thing like B, then E to A, then S to D, then C to I, and C to A also. And then also we will maintain the degree of each nodes, like what this degree says, like how many nodes are connecting directly with that node. So in this degree array we will maintain this type of things. Fine. So like after G it comes to B, and there is none any other node which is connected with the B, so we will shift to B, like we will append this B into our answer. And the same with the C to I. So here also like there is no any other node that is connected with the I, so we will append this I into our answer. Same with the D, and for the A, so we have to check like C is connected with A, so C is already cutted. Then F is connected with A, F is connected, B is connected with A, then E is connected with A. And then after, so here like a degree of A was 4, and here like these 4 nodes are already present in the answer, so we will append this A into our answer also. Fine. So like this only we can do this question. So let's move to the coding part. So let's get to first collection. So here first I am making the graph using default dict, and also I have to import DQ because we are going to use a BFS approach. And for I, and also we have to maintain the degree of each node. So degree of I equals to 0 into V. Then for I comma j in edges, also I have to make the default degree. Fine. So graph of I dot append j, and also degree of j plus equals to 1. That means that this u is connected with the v, or we can say this I is connected with the j, so the degree of j will increment with 1. Fine. And I have to make one dq, so q equals to dq. And for I in range v, so here I am checking those nodes whose parents are 0, whose there is no parent with for that node, so I am considering them. So if degree of I equals to 0, that means q dot append I. Fine. And while q, so this node equal to q dot pop left, and for neighbor in graph of node, now I have to decrement this first one, and then I will check with if the degree of neighbor is equals to 0. That means all are satisfied and all are present in the answer. So I will just append q dot append. I will append this neighbor into my dq, and also here I have to append this node into my answer. And at the end I will return this answer. Fine. So let's check this. Okay. Fine. So this code is successfully executed. So the time complexity will be big of v plus big of v plus e, and for the space complexity, so we are using this graph and we are using this degree array, so it will take big of n. Thank you.